Let f be given by x cubed plus 3x squared minus 24x plus 5. Answer the following. Find all the critical numbers of f. This is a polynomial, so critical numbers means find the derivative, set it equal 0, and solve for x. Then find the intervals on which f is increasing or decreasing. For this, we'll do the sign chart or interval test. So let me do it, okay? So here, first we want to find the derivative. So let me write here, derivative of this polynomial is 3x squared plus 6x minus 24. Okay. Now for part A, to find critical numbers or critical points, we need to set this equals 0. Let's solve for x. So 3, 6, 24, 3 divides all 3. So x squared plus 2x minus 3 goes 24 8 times equals 0. Now we should be able to factor this trinomial. X 4 times 2 8, and 4 minus 2 is 2, so plus means plus here minus here. Okay, 3 has no contribution in getting x, so x plus 4 0 means x equals negative 4. X minus 2 0 when x is 2. So we got two critical numbers, negative 4 and 2. So critical numbers means when we graph, if the graph is like this, then the x values where we have the top of the hill or the bottom of the valley, kind of these values. Okay. Now next, let's look at part B. These questions are related. So for B, where the function is increasing or decreasing, so we need to write down the domain of the function. So this is a polynomial. That means domain is all real numbers. Okay, so negative infinity through positive infinity. Now we need to locate those critical numbers, negative 4 and 2. So negative 4 to the left and 2 somewhere. So basically we got 3 intervals to test. Negative infinity through negative 4, negative 4 through 2, and 2 through infinity. So we pick a representative from each interval. Just take, I don't know, anything in between, negative 5, maybe 0, 3. Okay, we pick a representative from each interval and we plug that into f prime, okay, into the derivative. Plug these representative values into the derivative. So note that this is our derivative. So plug there. Okay, let me start plugging 0 because it's easier. 0, if we plug in 0, 0, 0, negative. So I get negative some number, negative 24, but I don't need the exact number, I just need the sign. So negative, just 1 or 2, okay, doesn't matter. Now let's plug in negative 5. 3 times negative 5 is squared plus 6 times negative 5 minus 24. Use your calculator, you are gonna get some positive number. In the same way, plug in 3. 3 times 3 is squared plus 6 times 3 minus 24 is going to be some positive number. And we know that when derivative is positive, that means the function is increasing there. F prime negative means the function is decreasing, now increasing. So we write in this way, f is increasing on where negative infinity through negative 4 and 2 to infinity. f is decreasing on here, negative 4 to 2. Okay, that's part B. Now let's do part C. Find the local max and local mean of f. So look at this sign chart. Okay, we just found the sign plus or minus of f prime. So this is interval test or sign chart. The function is increasing, then decreasing, increasing. So when function is going up, so the increasing, decreasing, again increasing. So this will be local maximum value and this will be local minimum. So local maximum occurs at negative 4. So local max, so they want value, means this is the location for local max. The answer is given from the function, local maximum value of f. Okay, so we plug in negative 4 here, that is f at negative 4. So we use calculator and get local maximum value and local minimum value. So let me write down local maximum value, local minimum value. Okay, I'm going to write in a moment. Evaluate the function at 2, f at 2. Okay, this will be a number as well. I used a calculator to get the value of function at negative 4, that's 85, and negative 23 at 2. So that's part C. Now in part D, we are asked to find the intervals on which f is concave up, down. So whenever concavity, concave up, down is involved, we need to find the second derivative of the function. Okay, so we already have first derivative here, over here. So let's find second derivative and then we can answer D and E. So second derivative, okay, just find the derivative of this first derivative. 3x squared means 6x plus 6. Now we can answer part D. Find the intervals on which function is concave up or down. Now we kind of repeat A. So here, when we are finding the intervals where the function is increasing or decreasing, we just use the first derivative. Now we're going to use second derivative for concavity, but everything same. So we set the second derivative 0, which is 6x plus 6, 0. Solve for x, subtract 6 from both sides, divide by 6, we get negative 1. So this could be a possible inflection point. Inflection point is the point where the concavity changes. Okay, now let's do sign chart. Again, domain is all the real numbers. Now we got negative 1 here. At this time we wanna check the sign of second derivative and we conclude about function. We take a representative here. Let's see, negative 1 means negative 2. Let's take 0. Okay, and plug those numbers into second derivative. Let's plug in negative 2. So we got second derivative here. I just need the sign plus or minus. So if we plug in 0, it's going to be plus. If I take negative 2, 6 times negative 2, negative 12 plus 6, that's negative number. And we know that when second derivative is negative, the function is concave down. Okay, so something like this shape. And second derivative positive means concave up. It's like cup, concave up. So we answer in this way: f is concave upward or concave up on here, right? -1 through positive infinity. F is concave downward on here, -infinity through -1. And note that at this number -1, the concavity changed from concave down to concave up. So we have an inflection point. We need to find that. Find the inflection point of F. There's only one. Point means X value and corresponding Y value. So we got an inflection point. That is -1, comma, corresponding value of the function, because point means X and Y. Number means just X value. So X and Y is always F at -1. Because we are answering about the function. We found first derivative, second derivative, just to get some information. Now that is -1, comma. Now we need to evaluate the function at -1. So I'm using my calculator. I get 31. Final.